Have you ever dived in the sea? Or maybe in the pool? Compared to many other aspects of swimming, diving is the most difficult activity. When diving, our bodies seem to be lifted upwards, so we need more effort to reach the bottom, especially if you swim in the sea. The deeper you dive, the more headaches you will feel, and your ears will also feel tight. Hmm, why do you think that could be happen? Hi everyone, back again with me, Miss Vina, in Learning Together. In this episode, we will learn about hydrostatic pressure, its relation with communicating vessels law, and its application in our daily lives. So, without any further ado, let's get started. By definition, hydrostatic pressure is pressure exerted by water in any direction at any measuring point, resulting in a gravitational force. This pressure will increase along with increasing depth measured from the water surface. This pressure arises as a result of the liquid at rest at a certain depth. The amount of the pressure depends on the density of the liquid, the acceleration due to gravity on Earth, and the depth of the liquid. The deeper the liquid, the greater the resulting pressure, and the greater the density of the liquid, the greater the pressure generated. In other words, pressure of liquid is directly proportional to density and the depth. Mathematically can be written as this equation. Water pressure at any depth is not affected by the surface area of the water, the weight of the water, or the shape of the water vessel. The gravitational force makes the weight of the water particles press the particles below it. Likewise, the water particles below will press each other to the bottom of the water so that the pressure at the bottom will be greater than the water pressure above. Yep, this concept explains why we feel more pressure that makes our head and ears hurt as we dive further down. The deeper we go, the more liquid there is above us, with its weight pressing down. For example, suppose we have a pool, let's say 3 meters deep. Then we want to know how much pressure you'll experience at the bottom of the pool versus how deep you are now, which is, let's assume 0.5 meters. Then, how do we need to dive in and feel the difference in the pressure on our head directly? Of course not. Even without being in the pool, we can still calculate it. All you need to do is find the difference in depth between the bottom and 0.5 meters. Then, put it into the formula for hydrostatic pressure. The density of water is 100 kilograms per meter cubed, and the change in distance to the surface is 2.5 meters, which means the pressure of the bottom of the pool is 24,500 pascals more than the pressure in 0.5 meters down. Talking about fluid and pressure will not escape from the communicating vessels. Actually, the concept is really simple, like the nature of water in general, where the water will change its shape according to the container. The concept is like a teapot. The shape of the teapot must be like this. The mouth of the top the teapot nozzle is never lower than the mouth of the teapot itself, for example only this way. Why do you think? Because if the mouth of the teapot nozzle is low and the teapot is completely filled by water, then of course the water will spill. When we have a container in the form of a connecting vessels, the water level will be evenly distributed throughout the vessels. Now, the problem is, what if the type of water we pour is different? In one pipe view, for example, we fill it with oil, while in other pipe, we pour water. Are the results same? The answer is of course not. Because the density of those liquids are different. It means that one of the two liquids is lighter, so that it can be above the other and not mixed. However, the interesting thing is that their pressure is the same. This pressure is what we can find using the concept of hydrostatic pressure. We just need to equalize it based on the height and density of the two liquids. We have to measure it from the surface to the lower bound of the two different liquids. Well, do you think the concept of hydrostatic pressure is not important? Because maybe it just connects with density, gravity, and depth? If you think so, you're definitely wrong. There are various benefits that we can find in our daily lives from this concept. First, the hole for the bathtub drain is placed at the very bottom. The deeper it is, the greater the pressure. As a result, if a hole is made at the bottom, the water will flow very swiftly and the top will drain quickly. Just imagine if the hole was put at the top. You definitely can't wait for the top to drain. Second, the bottom of the dam is made thicker than the top. You know the dam, right? The bottom of the dam will be thicker than the top because if it's made the same as the top, aka not accompanied by thickening, it's feared that the water will erode the dam. It's made thick in order to be able to withstand the pressure of the liquid. Third, infusion. Before placing the infusion, medical personnel will measure the patient's blood pressure. Why do you think it's necessary? Because intravenous fluids must flow into the blood. Meanwhile, the condition for drainage is that the blood pressure must be lower than the infusion pressure. Now, to get a deeper understanding about this concept in this episode, let's join the quiz. Just click the link here. See you in the next episode.